Subjects is here as a guest for Miss Riley to let you know that we are always here for you. We love you, even though we are not here with you in person. And we have a very special lesson today from Miss Riley. It is the Unit 7 mid-test review. So we are going to get to that in just a couple minutes. But Miss Riley did just send me here so that you could have a little bit of excitement, because she knows sometimes just listen to her talking video, listen to other teachers talking videos. Maybe it's not the most exciting thing, but DJ2 Subjects want to let you know that we're all excited about this learning time together. We're excited about showing Miss Riley what you know on the mid-unit 7 assessment on SchoolNet. Super exciting SchoolNet business. And to wash your hands. So, DJ2 Subjects, love you. DJ2 Subjects out. Going to get Miss Riley. Thank you everyone. Thank you studio audience. Thank you DJ2 Subjects for that wonderful introduction. Thank you again. So I did just ask DJ2 Subjects to come say hi to everyone. And I mean, I'm sure DJ2 Subjects would appreciate if you come out to the school dances and great things like that. And just like we said, we are going to review for the mid-unit testing. I'm going to get it set up right now. And what we are going to do is I'm going to go through the study guide. And if you have not done the study guide yet, what I would recommend is that you take some time, you pause this video or stop it, and take some time to go ahead and do the study guide so that you can compare your answers and see what you actually don't know and need a lot of help on. Or what you know really well, and can get back to me and be like, hey, Miss Riley, I'm really good at this, or anything like that, because you can always ask me questions on Remind, Classroom, email, Canvas, but you can also just like reach out and let me know if something's going really well or if you're really good at one of these new concepts. So we are going to start with number one. Number one says the inequality 1.3m is less than 9.6 obviously contains infinite solutions. Which of the following would be an acceptable solution set? So let's go ahead and talk about this piece by piece. Let's talk about the 1 3/10 m. So do we remember that? We should. That is our coefficient. Our coefficient is the number that's right next to the variable. It means to multiply. So this is telling us that 1 3/10 times something, or m, has to be less than 9.6. And remember, what makes an inequality different than an equation is that it does have infinite possibilities. That's why for inequalities, we have solution sets, whereas equations just have one answer. So for this one, the strategies that we could use to solve and find which of these three possibilities could be solution sets, we could either go ahead and solve this inequality like you got notes on earlier this week, which we would do through the inverse operation. So I'm going to put a little star by solve, because that's something we could do, and we could see if whatever number we get for m, the solution set would have to be less than that, because this is saying 1.3 times something is less than, not equal to, but just less than 9 6/10. So from there, we can also think that we can use the strategy of substitution, which we talked about with our variable equations as well. So I'm going to write sub out to the side over here. So we could solve, or we could use substitution. We could also try to plot it on a number line and go from there. So I can also write number line. But what I think would be the most efficient for this, you can use whatever you feel comfortable with. You know, I'm always good with you doing whatever works for you. But I think for this one, substitution is going to be the fastest, most efficient, and easiest way to get your answer. So let's start with answer choice A. I'm going to substitute, or remember that sub, put in for something else, substitute 1 for m. So I'm going to put 1.3 times 1 is less than 9.6. So if we do 1 3/10 times 1, we're going to get 1 3/10, which is less than 9.6. So that works. If we change that to a 2, which is the next number in our solution set, we get 1 3/10 times 2, which is 2 6/10, which is still less than 9.6, so that works. Then if we try the next solution in this solution set, we do 1 3/10 times 10. And remember, when we have a decimal like this, all we have to do when we multiply by 10 is move it 1 to the right. So then we have 13 is less than 9.6. And is this true? Absolutely not. So 10 would not work. Therefore, even though these first two work, A cannot be the answer, because in order for it to be a viable or acceptable solution set, each of the numbers has to be able to be substituted into the inequality and work. So, answer choice C. If we know, I'm skipping to C because I noticed that 10 is too great to work. So if 10 doesn't even work, then could 15 work? Absolutely not. And so on that note, could 21 work? No, that's even crazier. And then 13.3? Definitely not, because we're looking for something that you would multiply times 1 3/10 to get something that is less than 9 6/10. So we know that B is our only acceptable solution set. And to double check, we could substitute in each of these numbers, just like we did last time, and we could have 0.75. And we know if we're multiplying by a fraction or a decimal, something smaller than one whole, our product will be a smaller number. So we know that this could work. And same goes with 1/2, same idea. And then 1 3/10 times 3 is also going to give you something that is less than 9 6/10. I think it's 3 9/10. But that is how you would solve this problem. Miss Phillips, I forgot to give credit to you earlier, sorry, but is our wonderful iPad camera lady for this wonderful, exciting test review. Miss Phillips, does this make sense?
Yes, this is very clear.
And I'm checking with Miss Phillips because just like y'all know me, when y'all ask me for ELA stuff, and I'm like, I don't know that. Sometimes Miss Phillips, math is not what she teaches, so if I feel like if I can explain it super well to Miss Phillips, then hopefully that means that I'm not missing anything, because sometimes when I don't have people here to ask questions, I go fast and I'm like, I feel like that made sense. But obviously this isn't for me, this is for y'all, so that I can make sure that y'all are learning this super well. So let's go ahead and look at the next one. The next one is going to have the same idea. It says, which set of values means the same thing as solution set, would make the inequality 4p, remember 4 is that coefficient again, so 4 times p greater than negative 16. So I'm just going to go ahead and write it a little bit bigger here. So we know that 4 times something has to be greater than negative 16. 4 is already greater than negative 16 because that's just like what we've been learning about for a couple weeks. Anytime, if you have $4 in the bank, it's not great, but it's way better than owing the bank $16. So we know 4 is already greater. So let's go ahead and look at our first one. If we multiply, we're going to do the same strategy of substitution because since we determined that was going to be the most efficient, I'm just going to do the same thing. If we have negative 20, and we do negative 20 times itself 4 times, that's going to give us, let me just rewrite it for y'all. Negative 20 times 4 is going to give us negative 80. And is negative 80 greater than negative 16? No, because it looks like it's a larger number, but remember, like we talked about, the greater number on negatives is what's closer to 0. Always on the number line, whatever is located further to the right is going to be the greater number. So left is less. So if you're going further to the left of 0, it's going to be smaller because it would be way worse to owe the bank $80 than $16. So if it's negative, negative 80 would actually be less than negative 16. So we know the answer choice A, because it has that negative 20, will not work. We could try out the other two, but we don't need to. Because we're looking for a solution set that contains only numbers that are greater than negative 16 when multiplied by 4. So now, let's go ahead and look at answer choice B. Answer choice B, it's just 1, 2, 3. Let's try it out. So I'm going to substitute 4 times 1 is greater than negative 16. Oops, wrote my sign the wrong way. Be careful about that. So I have 4 times 1 is greater than negative 16. 4 one time is just 4. Is 4 greater than negative 16? Yeah. So this would work. So now I'm going to move on to 2. So I'm going to have 4 times 2, which we should know is 8. Is positive 8 greater than negative 16? Absolutely. So then the last one, so far the solution set is looking pretty good. But just to be sure, this last one, I'm going to do 4 times 3. So I have 4 times 3, which is 12, and 12 is absolutely greater than negative 16. So just to be safe, to make sure that it doesn't have more than one answer or that I am correct in all my math, I'm going to go ahead and look at answer choice C. Answer choice C has negative 1 as the first choice, and so 4 times negative 1 would just be negative 4. And negative 4 is greater than negative 16. So this would work. So then the next one is 4 times negative 2. So if we have negative 2 4 times, that's going to give us negative 8. And is negative 8 greater than negative 16? Let's think about it. What do we talk about with 80? Negative 8 is further right compared to negative 16, and it's closer to 0, so negative 8 is going to have a higher value than negative 16. So then the last one is just positive 2. We know positive 2 is 4 times 8. 4 times 2 is 8. And we know that 8 is greater than 16. So do y'all see what happened here? This one has 2 correct answers. Some of your questions on this test will have more than one correct answer. And it will say select all or which of the following. So you will not necessarily only be choosing one answer. So for this one, B and C would be your correct answer. So some of the questions you will have just one answer, but some of them you will not. So that's why you need to work out every single one of them, because if you had just gone, oh, B is right, I'm going to be done with B, that would have only given you half credit. Or, honestly, I'm not positive how school net grades, you may have not gotten any credit if you didn't get both of these. So, Ms. Phillips, do you have any questions if they don't have students?
I don't, but as a student, I might have done a number line to the side with a 0 in the middle, so I could have put some plot points on from 0 to maybe 5, 10, 15 on each side to kind of visually see where everything was as I was doing it.
I like that. And see, friends, this is why Ms. Phillips is awesome, and this is why it's good to have another person, because sometimes it's super easy to miss stuff. So I think that is a great strategy to have a number line that you can just reference and see right in front of you. So I think that is great for this problem. So we can go ahead and move on to the next one. The next one says graph the inequality negative 3 is greater than or equal to A. We just have the notes about this, so this is something brand new. Well, brand new as of I'm going to put this video up on Thursday, so this is brand new as of Tuesday, so not super brand new, but a little bit. So I'm going to go ahead and draw my number line, because remember, when you are graphing inequalities, it is not on an actual graph. Like I talked about in the video that I put on Tuesday, graphing inequalities is plotting it on a number line. So graphing inequalities, don't get freaked out and be like, I don't know how to graph that. Because all it is plotting the points on a number line. So we've been plotting points on number lines since like, I think literally kindergarten. So all it is different is that you're going to either have an open circle or closed circle on the dot, and you are going to make sure the arrow has the right direction. So I know here, the number that I'm going to plot would be -3. So -3 is gonna have an open circle or closed circle. Does it include 3 or not? Or -3? This line underneath the greater than sign tells me that it includes -3. So that means that my circle is gonna be closed in, because closed includes. So it's closed in because it's greater than or equal to. That means the answer could be -3, but it's also anything less than. So now we have to draw an arrow to represent A. A is everything that's less than -3. So this could also be written as A is less than or equal to -3. If this makes you feel more comfortable, you can always rewrite your inequalities. But if you're good with this, then leave it at that. So now I'm gonna draw my arrow. Left is less. So I'm gonna draw my arrow going this direction. And that's all you have to do for this problem. Does that make sense?
It does. I liked the alliteration of left is less.
Alliteration, it's good stuff. And yes, I know
Throw
the
in
word
those-
alliteration.
Throwing those ELA skills.
So now I'm gonna just scroll down real quick. Scrolling, scrolling, scrolling.
While you're scrolling, if it didn't include the 3, the circle would have just been an empty circle.
That brings us to our next problem, Ms. Phillips. Thanks for the introduction / segue. I don't know what it is. It segue? I think it's segue.
Segue.
But not like the segue you ride on. Those are cool too, though.
But I think that's because it takes you from one place to another. So a verbal segue takes you from one thing to another, like a transition. And I think that's why they're named
There
segues.
you go. So there's your mini ELA lesson, kids. I mean friends. I don't ever call y'all kids. So, as you can see, this problem also says graph the inequality. T is less than 2, which could be also written as 2 is greater than T. So I'm going to go ahead and draw my number line, because remember that's what the graphing is. So I'm going to have 0, 1, 2, 3, -1, -2, oops, wrote a 3, said 2, -2, -3. So now I know that I'm going to plot my number over the 2. This symbol shows me that T is less than 2, 2 is greater than T. So that means that 2 is not my answer. It could be 1.99999, but 2 will never be my answer. But because I don't want to plot my point like right here, which I've seen students do in the past, if you do that though, that's missing out on the 1.99999 infinity. So what you're gonna do is you're gonna go ahead and put that open circle over the 2. But you're gonna make sure that it's over the positive 2, because you're better than me. And I was like, 2, 2, 2. Turns out that's -2. This doesn't say -2. So I stand by my open circle, but that's why you have to check what you're plotting. I was so like into the negatives on the last one, but this is just a positive 2. So I'm gonna come over here to the positive 2, and I'm gonna do my open circle. And again, this says that 2 is greater than T, or T is less than 2. So remember, left is less. So my arrow's gonna go this way. Ooh, so exciting, such a beautiful arrow. There you go. Are there any questions?
No, but I have a comment.
Mm-hmm.
As a non-math person who is fully ingrained into I wonder, I have noticed that when you put the variable first, that the sign points in the direction in which you would draw your number line,
Yeah.
because that's the way in which that's where your answer's gonna come from.
Yeah, that's true. So, yeah, the answer is always gonna come from the variable side. So, I think a lot of times it is helpful to have the variable first.
Yes.
So that's why it's good to know how to write it and flip it to maintain the same thing.
Mm-hmm.
So, now, I'm gonna scroll and we're gonna look at the next one. Some of you may recognize your names.
We're at 20 minutes.
Before we get to the next one, I'm gonna stop this video and I'm gonna make a part 2, just so that they can all fit on Google Classroom. See y'all in approximately 5 seconds.